Okay, so in 810, they define a find function. In 811, they do more with it. 812, optional parameters. We're just going to skip right to 813 and the built-in find method. So we'll just take their banana and place that in here. Okay, so we've got banana, and then for that string it's called a method find. We just use a dot and then find, and then say, well, is that substring in there, and where does it start? So if I run this, it starts at index 2. So 0 for B, 1 for A, 2 for N. So what it did, now it's not so clear here, but what it did was it found the first instance of banana. So if I change this to AN, then it should give me a 1, because the AN starts at 1. But you see there are two occurrences of it. And so, and sure enough, see, it started at 1. But I can add to it, well, don't start looking until 2. Okay, now where did I come up with 2? Well, I just got 1 for the answer, and so I'm looking for another occurrence, a second occurrence. And so I could say, well, don't start looking until index 2. And in this case, it should give me a 3. And sure enough, it does. And you know, then I could look at from 4 on, and I shouldn't find anything. So if I put in 4 here and run that, it gave me a -1, because that's what it does. That's not an index. That's saying it didn't find it. Okay, so be careful with that. There is negative indexing, but that -1 there says it didn't find it. You can also give it a stop. For instance, I could start at 0, but then go until maybe 0, 1, 2, 3. So I could start at 0 and stop at 3. And there I get the 1. That's no surprise. But I could also then, I could start at 2. And now notice what happens here. If I go from 2 to 3, I think I'll get a -1. And I do, because the 3, again, it doesn't actually look at the third character. So it just looked at the N here, 0, 1, 2, N is 2. So it just looked there. But if I increase this to a, well, let's see, if I make just a 4, then I still shouldn't find it, because I haven't found the second N yet. So you see, it still doesn't find it there. But if I go to 5, which is, let's see, 0, 1, 2, 3, 4, 5. Yeah, that's that last A. But it doesn't actually look at the last A. It just looks at 3 and 4. Well, actually 2, 3, and 4. So I should get 3 out of this. And I do. Now, the interesting thing here with find is actually, I believe, say I take it to 7. Well, that should give me an index out of range, but it won't. See, I run that and it just gives me 3 again. So here's a case with find, you don't get index out of range. And so, you could try to print out, all indices, so of A's, say, for instance, or AN. So, I could do here, a 4 let's see, or actually, probably a while loop makes more sense. So while I is that's not supposed to be a comma, that's supposed to be a less than. While I is less than the length of banana, okay, so we'll do that. What we'll do here is we'll set index equal to banana.find, and here we'll call this I. We'll start at I, which means I need to initialize it. So I equals 0. And so while it's less than the length of the banana, we'll do this, and then we'll print just IX here. So that'll tell me that first occurrence, but I want to keep going, look for more occurrences, and so then I'll do IX equals IX plus, oh, well, no, so I want to do I, sorry about that, IX. Okay, so I'm going to add 1 to the IX and try that, and so let's see what happens if I did that. Okay. Oh, interesting. This is I need to interrupt the kernel there. The problem was I didn't think about the fact that we would return a -1. And so let's change this a little bit, and I'll fix, so see, I can have plenty of errors. So while I is greater than -1, and so we'll do IX, I, like that, print, and then I equal IX plus 1. That still may not do it, because that may produce 0. We'll see what happens here. So yeah, see, that's still an infinite loop, my bad. So I need to interrupt that kernel. So I gotta think a little harder about this. So so we'll start just IX. We'll start IX as 0, and while IX is greater than -1, we'll do this, then print IX, and I think, yeah, actually what we want to do, this is actually a little tougher than I thought. Sometimes something quite simple can be a little tough. So, I want to change that here at the beginning. So ix equals 0. And then I equals ix plus 1. And then we'll print ix. So here I hope I've taken care of it, because it'll come in, ix will be 0. And then, well, actually I probably want, I need to do two things. So see, this sometimes something that seems simple might be kind of hard. Maybe you all would have a better idea how to get at this, but so I'm going to let I equal -1, ix equals 0, so this will come in here. Ix will be bigger than -1. It will let I be ix plus 1. It will get a new ix from searching here on I, starting with I, and then I'll print that, but then it'll check the ix before it adds 1 to it again. So maybe we've got this fixed up now. And sure enough, there we go. So it says AN starts at 1 and 3, and that's it. So similarly, I could just do it with the A and run that. And so that's at indices 1, 3, and 5 are the A's, and then it's done. So you can find multiple occurrences by using loops. I could have done it with a for loop, I suppose, but I don't know that I'd use the find command in that case to do it. If I did it with a for loop, I'd probably check each character one at a time. Okay, so so that was pointing out we could start find somewhere and it would go to the end. You can also do something like print find in our banana here. I can give it an ending point, so I could say start at 0 if I wanted. I could start somewhere else, but I could also say, don't look any further than, well, let's go up to 5 actually, the last indice, and let's say we won't start until 2. And whoops. Oh, what am I doing here? So I want to find A. Got a little mixed up there. Sorry about that. From banana. So here's banana. Dot find. Okay, so this will print out those 1, 3, 5, -1, but then it should also give me 3 here for that middle A. Oh, what happened here? Fine. Oh, I had a quote, double quote on there. Not sure when I did that, but I did. Okay, let's try that again. And there you see we got the 1, 3, 5 -1, and then we got the 3, so I could have it start at 2 and only go so far. I could have also made that a 4, 2 to 4, and it would have still spit out that 3. Okay, so I think that'll do it for the find function.